Greetings of the day, dear students. In this video, we are going to discuss about the temperature dependency of PN junction diode. We are going to see what are the important formula we are having. Of course, we no need to have or do the derivation for this topic, right? And what are the different variables present in that formula, in those formula, and what about the relation of saturation current with respect to the temperature, I naught value with respect to the temperature, those things, and some important terminology related to the formulas. All those things we will discuss in this video. Right now, dear students, please observe. If you observe, when the diode is under forward biased condition, right, the current through the diode is given by I equals to I naught bracket of e power EV by kVt minus 1. Or in some textbooks you can also observe that I equals to I naught e power V by Vt minus 1. Either the formulas are okay. There is nothing wrong, right? So on referring different books, these two formulas we have obtained. Now in this formula, I naught indicates the saturation current, E indicates the charge of an electron, V indicates the voltage, Kb is the Boltzmann constant, and T indicates the absolute temperature. Absolute temperature. So the relationship is having some exponential term. Exponential term. The current through the diode is given by I equals to I naught e power EB by kBt minus 1. The common mistake you may commit is don't write this minus 1 in the numerator part. This is this entire term value minus 1. It is not something e power some x minus 1. That is the difference, right? Yeah. Here also this minus 1 is for e power v by vt. After calculating that value, from that you have to subtract the minus 1. Right? Yeah. Now in this formula, Vt is given by kBt by E. If we substitute the value of Boltzmann constant and charge of an electron, you used to get this value Vt as T by 11,600. Now I naught, the I naught value is given by some A naught T cube e power Vg naught by Vt, where again here A naught indicates the value of I naught at some reference temperature. Most of the times that reference temperature will be 25 degrees centigrade. Now Vg naught is the value of the voltage that is required to move an electron from valency band to the conduction band. Now depending upon the type of the semiconducting material used, this Vg naught will be equals to 0.708 volts for germanium, 1.21 volts for silicon. Or you can also observe that the saturation current of the junction is going to have a temperature dependency that is given by I naught equals to A naught e power kb bracket of Tg minus T naught. What does it mean? A naught again is a value of what? Value of the I naught value at some reference temperature T naught. So the value of I naught at some reference temperature T naught is denoted with letter A naught, and the reference temperature is is taken as 25 degree centigrade. Now Tg indicates the temperature of diode junction, and Kb indicates the Boltzmann constant. Now it is also observed that the derivative of log I naught with respect to the temperature, that value we are going to get it as 0.08 per degree centigrade if it is silicon, and it is equal to 0.11 per degree centigrade if it is germanium. And some more interesting key points also we can observe that you can remember these points. For every 1 degree centigrade rise in temperature, there will be a 7% increase of I naught from the initial value. And also for every 10 degree centigrade rise in temperature, the reverse saturation current denoted with letter I naught dash, right, will get doubled. For every 10 degree centigrade rise in temperature. and also the temperature coefficient of the forward voltage of a PN junction diode is approximately minus 1.8 millivolt per degree centigrade if it is silicon, and it is equal to minus 2.02 millivolt per degree centigrade if it is germanium. If it is germanium, right? Now this I naught, you can also observe, it is also given by this equation. Also I naught value is given by some a e ni square bracket of dp by lp nd plus dn by ln na. How do you understand this equation? What are the different variables present in this equation? A indicates the area of the diode perpendicular to the current flow, and ni indicates the intrinsic carrier concentration, Nd donor concentration, Na acceptor concentration. Now Dn indicates the diffusion coefficient for electron, diffusion coefficient for electron, and its value is given by mu n kbt by E. Again, where mu n indicates the mobility of the electrons, right? dp indicates the diffusion coefficient for holes, and its value is given by mu p kbt by E. Again, mu p indicates the mobility of holes, right? ln indicates the diffusion length of for electrons. lp indicates the diffusion length for diffusion length for holes, diffusion length for holes. So now if you observe this Ni, nothing but the intrinsic carrier concentration is a strong function of temperature. It is a strong function of temperature. So this is what all about the temperature dependency of PN junction diode. Clear? So dear students, in this entire discussion, the important point is you please remember this equation. I equals to I naught e power EV by kBT minus 1. And please write what are the different variables you are having. This formula will be simple and easy to remember. You please practice this formula. This is another option. No need to go for this option, right? If you write any one of the thing, marks will be awarded, right? And also you express how this value of I naught is depending on which parameters. Again, still I naught is depending, will depend upon some other parameters, right? In this formula and that formula, and simply express what are the different variable names you are having. These are the some of the points, some key points, right? Okay, thank you.